Okay, here is the second part of the video, which is solving inequalities by hand, no pictures. And, I'll be honest, it looks like it should be, I don't want to say easy, it looks like it should be straightforward. And we'll go over why it's not. Okay, so I'm going to guess some of you would be able to kind of come up with the idea pretty quickly to multiply both sides by x plus 5. Well, you do that. Cancels 8 less than or equal to 4x plus 20. And, well, you can solve this one pretty quickly, right? Here's the problem and the fatal flaw with this. And that's why I wanted to make this a separate video, because these innocent little problems actually are kind of slow. The fatal flaw is right here. We don't know what number the denominator is, right? Because x can stand for any number. We don't know if the denominator is going to be positive or negative. If x, let's say the denominator is positive, okay, multiplying both sides by x plus 5 is no big deal. But if, let's say x is negative 10, well, then that would be 8 over negative 10 plus 5, which is negative 5. You'd be multiplying both sides by negative 5, and then when you multiply both sides of an inequality by a negative, it's supposed to switch the arrow. So what actually happens is we have cases, which is like situational. And so you can't just super straightforward do these questions. What you actually have to do is set them up and solve them kind of logically and orderly, otherwise it's easy to lose sight of where you're at. So the way I'm going to set them up is we'll say case 1. Case 1 is when the denominator is positive. Awesome. Case 2 is if our denominator is negative. And you don't have to write greater than 0 or less than 0. You could write the words positive and negative, however you want to do it. So we're going to go through and solve this with the idea that the denominator is going to be positive. And honestly, that is going to be exactly what I had up there before. You multiply both sides by x plus 5. Because when it's positive, this symbol here doesn't get affected in any which way. So this next line would read 8 is less than or equal to 4x plus 20. And our idea is to solve for x. So I'll subtract 20. And then this would say 4x greater than or equal to negative 12. If you don't remember, you generally read from the variable towards the other number. If it makes it easier for you, you can flip this around. Like you can write 4x is greater than or equal to negative 12. Just make sure the arrow kind of follows with the x. Divide by 4, and I'm dividing by a positive 4, so nothing would flip or change. It's okay if my answer is negative, I just divide it by a positive number. So I've got x is greater than or equal to negative 3. Well, what you're going to have to do is you're going to have to take this denominator that we just found, and we had already decided that case 1 is when it was positive. So if I solve that for x, that would say x is greater than negative 5. So what I'm going to do is I'm going to say the answer I found and x has to be greater than -5. Because I basically found these answers saying this is on the condition that every number is bigger than -5 because the denominator had to be positive. So if I solve this conditional statement, so this was from chapters ago. If I'm solving an AND statement, it's kind of where they both have in common. So x is greater than or equal to -3 and x is greater than -5. If it helps you to draw them on a number line, do it. But where they have in common is x is greater than or equal to -3. So this is my first answer. Then I'm going to go over to case 2, pretending that my denominator is negative. So I'm going to start the problem over. And I'm still going to multiply both sides by x plus 5. But because I'm assuming that x plus 5 is negative, on the next line, my inequality would switch because I multiplied both sides by a negative number. And this would still read 4x plus 20. And I still go through and solve it. Subtract 20. X is less than or equal to -3, and if you want I can write that the other way around. Keeping in mind that we decided that x plus 5 is less than 0, negative. So we were saying that x was less than -5. So we basically went through and we said x is less than or equal to -3 on the condition that all of the numbers are smaller than -5. So if I solve this AND statement together, x is less than or equal to -3 and x is less than -5, that's where they have in common. So if you would graph that on a number line, you would see that they only have it in common. X is less than -5. And then your final answer to the problem. So basically we said if the denominator is positive, we got this answer. If the denominator is negative, we got this answer. Well, our final answer is going to be the left or the right. It's an OR statement. So we would say x is greater than or equal to -3, or x is less than -5. And if you were to graph this on a calculator or Desmos, you would see that the graph corresponds to this. And you could certainly write it. You could certainly write it in interval notation if you wanted to. X is less than -5 would be written as -infinity up to -5 parentheses, or greater than or equal to -3. Oh, excuse me, would be a bracket at -3 to infinity. So you could kind of write it however you wanted to, but you would find that this matched up with the graph. So this is the setup for how you solve it algebraically. Now, it is super easy to get confused with all the details. I did my best to try to lay it out to kind of separate it, because my brain can get overloaded with details. So I usually try to physically write down information so that I can kind of separate things to myself. And then that way I can organize my info and put it together all at the end. So using this as a guide, why don't you guys try to solve this one on your own? And pause it here, take a couple minutes, go back and forth, see if you can figure it out. And here's what you should have gotten if you solved this one algebraically. Now, I wanted to set it up exactly like the other one, so they're very similar. You just basically have all sorts of different number information. But these go real slow. I mean, I'm not gonna lie. You guys have already figured this out by now. They look super innocent, super easy, but they're filled with all sorts of details just because of the inequality symbol. And because when you have divided by zeros, it screws things up. And when you multiply by negatives, it makes things opposite. And so there's all sorts of details of these. And it makes what looks like an innocent problem have a lot of detail. Okay, well done. That is the end of chapter 8 on rationals. Nice job.